Good morning, Amy. How are you doing?
Good morning, sir. Yeah, I'm doing well. How are you?
Very good. Last time we did see how do we sketch sinusoidal functions. Is
Yeah,
that concept clear to you?
yeah, really clear. I tried questions from my book, a couple of exam questions, and yeah, it seems to be following the method that you said last
Okay,
lesson.
good. So you say, can you describe me the method in a couple of steps of
Yeah,
sketching
so
sinusoidal function?
so when I did them, I made it as concise as possible because obviously there's like a lot to do. But I so first started off by drawing the axes.
Hmm.
So you always look at like, is it y equals 0? Is it y equals 2? Let's start from there. And then we're looking at the amplitude. So
Correct.
that's when we're looking at trying to find your maximum and minimum points. And then you look at other like transitions, maybe reflections and things like that, whether it's cos or things, and then leave the horizontal translations last. So
Correct.
that'll be your last thing to do. Yeah.
In
So
between, you have to look for the time period. The value k will give you the time period, and time period will be 2 pi divided by k if you're working in radians, or it will
right.
be 360 divided by the time k to give you the time period if angles are in degrees, correct?
Yeah.
So once you have this time period, then you already have the vertical frame, the axis maximum minimum, which is given by plus and minus amplitude, and then
Mm-hmm.
time period gives you the boundaries. Split this time period into
Cool.
4 equal parts, and then
Yeah.
if it is a sine curve, start from the axis, go to the top, back to the axis, go to the bottom, back to the axis. Sine curve. If you have to sketch a cosine curve, start from the maximum
So,
axis, minimum axis, maximum, cosine curve is done. That is our first
yeah.
part. Second part is look into the phase shift. If the phase shift is, let us say, 30 degrees to the right, move each of these 5 points 30 degrees to the right, show by an arrow that they have been moved, connect these points with a bold line, and you are done with the graph. Is this clear to you?
Yeah. Really cool.
Your questions on domain, range, and everything will be answered from this graph itself. And in the coming classes, we will also see how do we solve trigonometric equations from the graph. Basics.
Oh,
If I say this particular sine function is equal to, let us say, 0.5, you only have to draw a horizontal line at y equals to 0.5 and check the points of
all the
intersection to
solutions.
get the answer. Since sinusoidal functions are periodic, you may add a parameter. Uh, if it is the k value is 1. In that case, 2 pi or 360 degrees is what to be added. And if it is the k value is different, then you know the
Right.
time period. So multiple integral multiples of the time period will be added to get the other answers. Is that clear to you?
Yeah. And then we also
Perfect.
kind of learned what was it about the graphical method and then the algebraic method, when
Algebra.
it comes to domain and range. And then if you kind of do it with like coordinate points, and then you basically, so let's say this is the x values, you look at all the x values in that equation and say what is happening to that coordinate point. So yeah, work like that. Also, it helps to figure out the domain and range as well.
Correct, correct. So basically, you have to draw the mapping that x and y will be mapped to a transformed function where x will be now mapped to 1 over k times x minus p if p is a phase shift. And the
Yeah.
y value will be a times y0 initial value plus the value of q if q is the translation,
Oh,
vertical
yeah.
translation, a is the vertical stretch factor. So you get your image points, and from those 5 key points which we had talked about, we can get these corresponding 5 image points. Joining them gives you the curve straight away. Perfect.
Yes.
And what you were describing is how do we find domain and range algebraically? That also we did perfectly
Right.
fine. Solving kind of inequalities, right?
Yeah.
So now that brings us to very good level. I'm sure you have understood all this. Today, we are going to talk about the tangent ratios and their curves. So we have done the sinusoidal functions, which means sine and cosine graphs.
Brilliant.
Now we will see today how do we very easily sketch the graphs for tan theta, right? These
Yeah.
are much simpler than the cosine graphs. Since in
Oh, really?
tangent function, yeah, they
Never found it
have
easy.
the
So
odd
hopefully I will.
symmetry, which we are going to explore, and only 3 key points to work with. The other two are basically the vertical asymptotes. So they make the frame is already made for us because of the
Right.
vertical asymptotes, right? So let's
Yeah,
get
yeah.
into that. So I'll share with you the lecture and we'll begin from there.
Okay, perfect.
Perfect. Can you see my screen?
Yes.
Great.
I
So,
can.
so let's talk about, it's a very small print from my book. A lot of material on this page, but I'll explain you what it is, right? Can you read something? What
Yeah.
is the title given here? Can you read that?
The graph of tangent and cotangent functions.
Great, great. So this is what
Yeah.
we talk about, right? So you can read, that's good. It's actually small for me. Anyway, so when we talk about tangent ratio, let's try to understand what we are saying, right? Since we are also talking about a graph, which means full 360 degrees. So I'll actually make the coordinate plane here and then make a right triangle in our first quadrant, right? This is our first quadrant. And let's say we have a point here, P, and the value of a point is XY, right? So that really means that the the x coordinate gives you the adjacent side, right? So this is your x value, correct? And this is
Yeah.
your, let me write it in the middle so that you understand that the length, which is the adjacent side, is x, correct? And this is y for us, correct?
Hmm.
If this is the origin, we are talking about uh, quadrant 1 now. Is that clear? Of course, we have four quadrants. This is quadrant number 2, that is quadrant number 3, and that is quadrant number 4. Is that clear to you? In quadrant 1, everything is positive. So if this angle is theta, we can write tan theta as equal to what? Tan theta is this side which is opposite, which is y for here, and the adjacent, which is x. So that is tan theta for us. Clear?
Yeah.
So this ratio gives us the tangent value. Uh, right. Now, if we have a point which is in second quadrant, for example, here, correct? So any point here will have the x value is negative, correct? So
Yeah.
as far as tan theta is concerned, it is going to be positive in quadrant 1, and it is going to be negative in quadrant 2, right? Because in quadrant 2, if I take a point, for example, it will be like minus 3, 4, for example, correct?
Hmm.
So as you can see, the ratio 4 over minus 3 will be negative, and
Right.
therefore tan will be negative, correct?
Yeah.
But in quadrant 3, it will again be positive because
Positive.
here the quadrant point will be now minus 3 and minus 4. So when you do the ratio of minus 4 over minus 3, you get a positive number.
Right.
Do you
Yeah.
see that? So that
Cancel.
really, yeah, that really means that if I extend to this, then the tan values are same because this angle is again theta. Do you see that in
Oh.
quadrant 3? So it is again same. So that means that the period for tangent function is what? 180 degrees or pi. Because it repeats after pi, not after the full circle. You get the idea?
Oh. Or sine and cos was after the full circle.
You get the idea?
Yeah.
It is positive in quadrant 3, and now you understand that the cycle, the time period for tangent is actually pi, and
Oh.
it repeats after 180 degrees, right? So either way, radians and degrees, very important to understand, right? So that
Yeah.
brings us to a very important conclusion, and that is to say that if I really want to sketch a graph of tangent function, I just need to work on this region 0 to 2 pi. Because after that, I mean 0 to pi. After that, I can repeat it and get the whole curve.
Oh, I see. Yeah.
For
Yeah.
sine and cosine, we were working from 0 to 2 pi or 0 to 360 degrees, because
Yeah.
that was their period.
Right. Right.
So first thing first, when we work on tangent functions, we have to only look into half the circle, which
Mhm.
is 0 to pi or 0 to
180.
180 degrees, which gives us full information. You get the idea?
Right. Yeah. Because
Does
it
it
repeats after 180. Yeah.
after 180? First thing. Second thing, which is very important to understand, is that tan of let me write here. We are randomly placing the values because we should be used to chaos, and then we can actually sort out things very easily. You understand?
Yeah.
That's what we do, right? So if I take an angle which is tan of minus theta, that is to say that this, I mean, you can see now that quadrant 2 will be same as quadrant 4, correct? This is negative, this is also negative because it repeats. Do you see that?
Yeah. Yeah.
That really means that if I am working in quadrant 4, that is, if I take an angle which is minus theta, because we are doing clockwise, right? So
Yeah.
clockwise means negative, correct? So if I do minus theta, the value which I'm going to get is negative, right? So tan of minus theta is basically equal to what? It is equals to minus of tan theta,
Which
right?
is the flipped in that quadrant too.
Right. So if I have a value which is 3 and 4 here, then the value here will be 3 and minus 4. You get the idea. Just the
Yeah.
value will be negative of what it was in quadrant 1.
Got it. Yeah.
So it really means that even if you work in quadrant 1, even if you work in quadrant 1, you can produce what is in quadrant 2 because of the nature that tan of minus theta is equal to tan theta with a
Yeah.
negative sign. You get the idea.
Yeah.
So what we actually have to do is only look into the tangent ratio values for 0 to 90 degrees or 0 to pi by 2.
Oh.
Not even the half circle. The quarter circle can work
Yeah.
for us because we
With
know
90.
that.
Oh,
Or
because then
I
you
can
can
also,
figure out the other one.
yeah, because I
Yeah.
can also write this as tan of 90 plus theta is equals to minus of tan theta. You get the idea.
Makes
Because
sense.
if I'm making a here, then this angle is, for example, let's say phi, then actually this angle is what? I mean, if I have to, I should not write like this. I should not 180 minus theta. Sorry. Tan of 180 minus theta. I should write. So if this angle is theta, right? If this angle is theta, then
That's
the
one.
other angle is 180 minus theta. You get the idea.
Yeah.
So tan of 180 minus theta is basically minus tan theta because tan is negative here.
Yeah. Yeah.
You get the idea.
Yeah. That's
So,
clear.
so we have to only work for 0 to 90 degrees to get the whole picture of tan over the complete domain of real numbers.
Oh. Yeah. Yeah.
Okay, correct. So therefore, now once you've got this concept, the thing which you have to work on is shown here. If you see this, key values of tangent function from 0 to 90 degrees. So I am only going to discuss with you the three values which are of key importance and they happen to be between 0 to 90 degrees. If I
Oh.
know the values of these three, correct,
Yeah. You can
I
sketch.
know the whole graph. I know the whole graph. You get
All
the
right. Yeah.
So what I'm saying here is I've actually written the values in x in degrees here, as you can see, and x in radians on the other side, because at this stage, when we are teaching the graph of tangent ratios, some students are still working in degrees, correct? They
Yes.
need
Yeah.
to know how to sketch the graph of tan, right? So in the very first table, I'm working with both the units simultaneously. So I'll be switching
Yeah.
from degrees to radians, radians to degrees, since you're also switching, correct? You
Yeah. I'm
are
switching
familiar with degrees and you are getting
degrees.
into radians. It's kind of a bridging time, right, between the two.
Yeah.
So we are absolutely clear about any one of them, right?
For sure. Yeah.
So when we talk about 0 degrees, right, or 0 radians, in that case, the line is just over the x-axis, theta is 0, right? And clearly the opposite side is 0 because any point over here, let me take point which is 1 unit away. So a point will be 1, 0, right? So
Okay.
the tangent ratio is what? The tangent ratio in this case will be 0 over some number. And 0 over any number is just 0, right? So we get first point to begin with is 0, correct? So
0,
we get
0.
that first point. Now, as we increase the value of theta, tangent ratio will increase because the y value increases, correct?
Right. Logically,
So
that makes sense.
opposite
Yeah.
side may increase. So when it comes to 30 degrees, then we have a critical point, which will be square root 3 over 3, correct? So we'll get this particular point, and 30 degrees means pi by 6 for you. And as we go to 45 degrees, it is an isosceles triangle with the opposite side and the two legs, the opposite and adjacent being of same length. And therefore, we have 1. And for 60 degrees, it will be square root 3 greater than 1, correct? And for 90 degrees, the adjacent side has now become 0. If you divide by 0, what do you get? Undefined. That is a
Undefined error.
vertical asymptote. Do you see that? So
Yeah.
we have a vertical asymptote, very important thing to understand at 90 degrees. So what you really see is that these critical points can be now plotted on a graph, and there we see the graph, correct? So we have to only look into the quadrant one, which really means that at 0, we have the tangent theta as 0. When I increase it to 30 degrees, then it is square root 3 over 3. Basically, we can look into this special triangle, correct? So let me just make this special triangle now for you, which you remember. 30, 60, 90, correct? So let's say this is 60 degrees and this is 30 degrees. That is 90 degrees. Just remember this triangle, correct?
Mm-hmm.
There you go. So for 30 degrees, it is 1 over square root 3. So it is 1 over square root 3 here, the exact value. And on this side, it is square root 3, correct?
But when sketching, it's hard to draw really accurate graphs because the numbers are really bad.
Yeah,
Like
so
0.58.
yeah. So square root 3 is a good, right? You know how to sketch, how to get the exact value of square root of 2?
No.
I'll tell you. It takes a minute, right? That is how Egyptians used to do. These are irrational numbers. Even today, we don't know how to exactly sketch square root 2. Square root 2 is something like this. If I have a side which is 1 unit long, and I can always make perpendicular 1 unit long, right?
Yeah.
Then in that case, what is the hypotenuse?
2 squared add 1 squared. Root
1
3.
square plus 1 square is square root 2, right? This is 1 unit.
Oh, sorry. I saw 2. Yeah. 1.
Yeah, right.
Okay.
So square root 2, you get the idea. So do you know you can just take a square root 2 exact value. And now to get the square root 3, what I will do is I will just make another 90 degrees and make 1 unit here, right? And this length will be
2
square
plus
root
1 root 3.
3.
Wow.
So drawing exact value of square root 2, square root 3, and so on is actually very important for students to learn, not a part of trigonometry at present, which we are doing. How? It is the basic. When we begin trigonometry, we begin with right triangles. And for me, that is the best right triangle to study.
Oh,
So
yeah,
you can
that's
go
so
in a
cool.
spiral, you can go in this spiral and produce all the square roots.
All
Very
right.
beautiful
Really?
stuff. Yes. Try to make it, you'll love it.
Oh, cool. Okay. So then you just do the next one like that and then just keep going.
Keep going. And my question to you is,
Will it stop?
yes, what is the maximum length you get? So square root of n is the maximum length you get in this full circle. What is the value of n? This is a question which is asked in competitive exams at a very high level.
Yeah.
If you want to get
Because
admission
if
to
you had like square root 4, it's just going to simplify back. So I need to find the maximum value which would stay
square
as
root 4,
that.
5, 6, 7, and you'll be surprised. It's like it's more than square root. N value is more than what? Anyway, I'm not telling you the answer, but go through it, one full circle, and figure out what should
N
be
is.
n, so that goes without overlapping, correct? Because as you can see, this thing will go like this, right? So I don't want to. I want up to here. What is the maximum value which you get, right?
Okay.
You get the idea.
Mm.
Very beautiful question. I've seen it in many test papers, including joint entrance examinations for institutes like IITs, MITs. I mean, Cambridge.
All right. Yeah.
Very good question. Okay.
Wow.
So anyway, and there we go. So anyway, so we have this. All right. So two triangles which we are basically working with are the special triangles. These are 30, 60, 90, and 45, 90, 45, right? So 1, 1 square root. Oh, 1, 1 square root. Is that clear to you?
Yeah.
Many times this 45 degrees, what we do is we multiply by square root 2. Not when we are working with tan theta, but with cosine, what we do is we make this as square root 2 and make this as square root 2, then this becomes 2, right? Because in sine and cosine, hypotenuse comes in the denominator, you need to rationalize. So it is better to draw this diagram where hypotenuse is not an irrational number. It is 2. You get the idea. That's the whole idea.
Yeah.
So that is why sometimes we use the other right triangle to get the exact value. Is that okay?
Oh, yeah.
So coming back to the graph for tan, right? So we are doing tan theta. Let's get back to tan theta. So we have seen that at 0, there was 0. At 30 degrees or pi by 6, it was 1 over square root of 3, which could also be written as square root 3 over 3, correct? And
Mhm.
then at 60 degrees, which is pi by 3, its value is square root of 3. And once you have these 3 points, you have a curve here. And if the values are negative, we expect negative of these values, right? So here we have negative 1 over square root 3, and we have negative square root 3. Does it make sense to you?
Yeah.
Well, 45 degrees is not shown here. 45 will mean we have, let me write in radians, pi by 4 will give you 1, correct? As you can see here, for 45 degrees, the legs are of the same length. So their ratio is going to be 1. Clear?
Yeah.
Now, when you reflect these points, because tan theta has an odd symmetry, right? We just figured out it has odd symmetry.
Yeah.
Odd symmetry means it is symmetric about the origin, and therefore I will symmetrically reflect it on the origin and get my second half. You see that?
Oh.
So from the values between 0 to 90 degrees, we got the whole value, whole range within the period of tan theta, which is from minus 90 to plus 90. So that gives me 180 degrees, right? Going from minus 90 here, right? So we have minus 90 to plus 90, correct?
Just
So
a
that
quick
means,
thing. When you say symmetric about the origin, are you saying, let's say, y equals 0, x equals 0? Because that's the origin is 0, 0. Or,
yeah, okay. Symmetric about origin means that,
yeah.
there are many graphs which are symmetric about, for example, y equals to x. Do you see y equals to x? So y equals to x, y equals to x cube, all these functions are symmetric about origin. That
Mm.
means if I draw whatever graph on the first quadrant, the same thing is reflected with mirror at the origin, and it comes on the third side, quadrant tail.
Oh, I see. Yeah,
For
yeah.
example, the
Yeah.
straight line, will be kind of like this, right? Kind of like this, right?
Yeah.
So which is symmetric about the origin.
Oh, because the origin is there and then it's just flicked there, but it's just a straight line because it joins up. Okay.
Yeah.
So if it's even symmetry, is it symmetric about the y-axis?
Yes, like a parabola, y equals to x squared.
Okay.
Yes.
Okay.
Absolute function, y equals to absolute value of x. So
Oh.
these are symmetric about. Now coming back to sine and cosine, cos function is symmetric about the y-axis. It is even. So
Y-axis.
cos is even, as you know,
Yeah.
cos theta is even,
Sine and tan are odd.
sine and tan.
Okay.
Make sense?
Yeah.
Okay, great. So as you can see, now let's get back to 90. At 90, when we draw the triangle, the adjacent side is 0. You're dividing by 0, which is not possible. What you get is a vertical asymptote. So this is your vertical asymptote.
Okay.
At x equals to, or we can say theta, because we are just putting theta there on the x-axis, theta equals to pi by 2, right?
Yeah. 90. Yeah.
Even for minus pi by 2, it is going to be a vertical asymptote, correct?
Mm.
So what we say is the odd multiples of pi by 2. So I'm write 2n plus 1 times pi by 2, we have a vertical asymptote. Because even multiple will be like pi, correct? For pi, it is 0. You see that?
Mm.
So odd multiples of the pi by 2 gives you vertical asymptotes for a tangent function.
So just a quick example. So if you, what would you put as n then? Like any?
Any integer, n belongs to integers.
Okay. In degrees or just a number?
Number. So integers z, they write with a bold face. They put double bar here. That means earlier
Yeah.
days when they're bold face, right? So that double bar. I prefer
Yeah.
only to cut it like this, which is not the right way, but still, you get the
Oh,
idea. Got
yeah.
used to it. Okay. Anyway, so n belongs to integers in this particular case, right?
Oh,
So let
yeah.
me just show you a bigger picture where we have many graphs of tangent and over a period of time. So what we will do here is, see, you have understood the tan theta graph, right? So we have tan x already plot for here, right?
Yeah.
Between minus 92 plus 90. Now that is the cycle which is repeated. So if I say draw the graph between, let us say 0 to 2 pi, then you are going to repeat this whole portion, correct? So it will start here and you keep on repeating and you can actually get the whole graph, correct?
Don't you have to draw another asymptote at 180?
Yeah. So first
Oh,
thing, in this case, after every interval of 180, I mean, odd multiples of pi by 2 or 90 degrees, draw the
yeah.
vertical asymptotes.
Okay.
Divide the portion into two equal parts and then repeat the curve. Done. You're done.
Oh.
You see that?
Mm-hmm.
So that's all we'll do. Let's take up more functions. So here is how I'm going to show you. How do we sketch a tangent function for a longer period, right? Repeating
Yeah.
the same thing. So what we just now learned is that between minus pi by 2, and on this scale, look here now. This is your vertical asymptote. That is your vertical asymptote. And these two vertical asymptotes are in minus 90 to 90 domain.
90.
Degrees. And now what I'm going to do is after every 180, I mean, this will be like 270, correct?
Yeah.
Odd multiples of pi by 2 or 90 degrees, I'm drawing these red lines, which are vertical asymptotes. Do you see that?
Mm.
And what we do here is we just mark a point in the center of the vertical asymptotes. We just mark this. These are the zeros for tan theta. So if the equation is tan theta equals to 0, those are the zeros which are our solution. Do you get the idea?
So yeah, so you just need to draw the two asymptotes and then find the center, and then that's your
Which
zero.
is a 0. And once you're done that, then you know the critical points, and there are only 3 critical points. One is for 30 degrees angle, the other one is for 45 degrees, and for 60 degrees. For 30 degrees, it is increasing, right? So, remember, this is 1. It is increasing. For 45, you have an isosceles
Yes.
right triangle, and the other factors are square root 3. Obviously, when you divide by square root 3, you get a smaller number. And so you don't have
Yeah.
to break your mind on this. Correct?
Mm.
Do you see
Yeah.
how
Yeah.
easy tan function is? Don't have to think about any triangle, whatever. This is it. So you
Oh.
get these 3 points and you plot first 1, 1, or very easy to figure out the other 2 points on the either side of 1, 1, right? 1 over square root 3, and you were figuring out how will I sketch accurately 1 over square root 3,
Yeah.
decimal point 5 something something, correct? Don't
Yeah.
break your head on this. We are saying sketch. When we say sketch,
It's
we
not
have
accurate.
rough. There's a difference between sketch and graph. You understand?
Graph is accurate.
So if it is a word sketch, I will suggest make the center point, which is 0, and then at 1. 1, 1 accurately, you can do it correct.
Yeah.
Now, don't worry. Just then you sketch the graph, and you can read from the horizontal axis where is 60, where is 90. Wherever your graph crosses, just mark those points as
Point.
square root 3 and 1 over square root 3. You are done.
Yeah.
That
So
is the
draw the
sketch.
graph first and then mark. Don't do it the other way.
No.
Because you want it to look, yeah. Because I always draw the points and then I try and cross, and then it looks so bad.
You
Okay.
don't even have to make a scale. What I'm trying to say here is,
Yeah.
you just make the vertical asymptote the center point and the graph, and then you make a scale where your points are 1, 1, and you have to
You're
write
done.
these values here, right? Now, if this is my 1, 1, I will write 1 here, right? I will write 1 here. Why will I write 5 and 6? I will not write anything else. I
Yeah.
will only write 1. I'll write 1 and I'll write minus 1. Do you understand? And my scale is defined. Why should I write so many things on the vertical axis? No.
That's true.
Scale.
Oh.
I have given you the scale. We are working at a very high level, year 12, year 13. You get the idea.
Yeah.
It's
Yeah.
not a KG grade 1 or 2 class where we are going to spend time on writing 1 to 10 on vertical scale. No,
Right.
it is
Yeah.
waste of time.
Oh.
You get the
Yeah.
idea?
Yeah.
So
Yeah.
you
It's
understood
clear.
what I'm trying to say, correct?
Yeah.
How easy the graph is. What do you say?
It is very, yeah. I wasn't expecting it, because when I was just thinking with sine and cos, I like understand it. But then that has 5 key points because of the vertical asymptote, because it's already kind of made your domain, your like range is made for you. You already got a frame to work in that you can just draw it straight. Like there is no other place you can draw it because it's already done for you, and it's only 3 points to create like key points. So yeah.
Periodic function repeated. Simple as that.
Right.
And period is 180 or pi. You understand now? You get the idea. Okay, I'd like you to read the properties of the tangent function. Let me just increase that for you now. Can you please read what have I written here for properties of the tangent function?
Yeah. So domain is set of real numbers except odd multiples of 90 degrees or pi by 2. The range is set of all real numbers. It is always increasing in its domain. The vertical asymptotes are at odd multiples of 90 degrees or pi over 2. It has an odd symmetry or symmetric about the origin. And then its period of tangent is 180 degrees or pi. X-intercepts are at multiples of 180 or degrees or pi. And then y-intercept is at the origin.
Okay. So simple. So you can see that the x-intercepts are at n pi multiples, right? So n belongs to
real is
integers. You get it? So both sides you can. That is what tangent function is. Very beautiful. And always increasing graph, right? Always increasing graph. So you have understood clearly how to sketch a tangent function, right? Let's move forward. Okay, so let's see, please. So what you really saw is tan is also a ratio of sine over cosine, right? You know that, correct?
Yeah.
So tan is the ratio of sine over cosine. And very clearly, cos x is not equal to 0. That means cos x is 0 as odd multiples of pi by 2, correct?
Yeah.
So that means x is not equal to, if you're working in radians, you can write pi by 2. So we have 2n plus 1 times pi by 2. If you're working in degrees, then it is not equal to 2n plus 1 times 90 degrees, and where n belongs to set of integers. Is that clear to you? Correct. Very simple. Now, we are going to look into the transform tangent functions, right? Just as we did sinusoidal functions. Right. So I'm taking a general equation without phase shift first, because as you know, I prefer to keep phase shift at the second stage. So first we have to sketch the function without phase shift. Clear? Okay. So therefore, my transform function for tan is a tan kx plus q. Clearly, a is what? A is the vertical stretch or compression. K is the horizontal stretch or compression by a factor of 1 over k. Q is translation up and down, vertical translation. Clear? So if that is the function, then the image point will be what? The image point will be x divided by k. The values of x will get divided by k. We're not looking into phase shift now. We'll look into it after 5 minutes. And the value of a will be multiplied by y plus the translation vertical up and down, which will give us the final image point for y. Is that clear to you?
Yeah.
Perfect. And the other two critical things for tan graph are the vertical asymptotes. Since we are not changing the phase shift, I mean, we are only changing the period. Therefore, now, depending on the value of x, do you see this value of x? So instead of pi by 2, it will be pi by 2 divided by k, right? Because we have compressed or expanded the graph, correct? So we'll take some examples to make this point absolutely clear, right? So now I would like you to read what are the key characteristics of the parent function. We are looking at the key points now, please. Can you please read these 3 key points?
Yeah. So points x, y. So you've got A being minus 45 or minus 1, B being 0, 0, and C being 45, 1. Okay. You've got the vertical asymptote.
Yes. So what I'm trying to work on is in between this period, which is minus 90 degrees to 90 degrees, correct? So we have key points, which are 1, right? 2, which is 45 degrees. Do you see, I've only come down to 45. I've forgotten your square root 3. I don't need it, correct?
No.
So these are the 3 key points which I'm going to work with. Minus 45 on the left side, 0 at the origin, and 1 on the 45 degrees, 1 on the right hand side. 3 key points I have. And then next is what? Vertical asymptote at minus 90 and 90, which I'm showing here, correct? So this is 90 degrees and 90 degrees plus and minus, because the period is all this. 180 degrees is my period for tan, right?
Yeah.
And the graph is very simple. The graph is, we are approaching infinitely large value, and there you go, right? So that's the graph which belongs to tan theta. Is that clear to you?
Oh, I don't know why I found this so hard. I made it look like it was so complicated. Yeah, because the key points you've chosen are so you can't make a mistake with those points. It's so accurate. Everything else just follows.
If your teacher are very fussy, they are many times like me, right? Sometimes they are very fussy. And they want 5 points to be shown. Don't bother about it, right? You say, oh, my 5 points are here. Don't worry. Don't just draw these three and draw approximately just draw these two. Is it okay?
Yeah, yeah.
And this is, you know, what is 30 degrees.
But
And
because
this
I
is
know the values of 30 and 60 and stuff,
yeah,
I can just
1 over
label them.
1
Yeah.
over square root 3 and square root 3, right? Don't even write the
Yeah.
decimal values. Write
No.
accurate values 1 over square root 3 and square root 3. Done.
Okay.
I'm not going to do anything else. In my
No.
graph, what I will do really is I will mark this point as 1, this point as -1. Do you see y-axis? I'm done, correct?
Yeah.
And I'll put 30, 60, 90, 30, 60, 90, and I'm done. My graph
Yeah.
is over. On the
That took 2
x-axis, I'm showing
seconds.
30, 60, 90, 30, 60, 90 with a negative sign on the left-hand side, and plus and -1 on the y-axis. Nothing more than that. Is
Right.
that clear to you?
Yeah, very.
So this is the perfect graph. What is very important to understand here is that this is always an increasing function. And sometimes we are looking into behavior near asymptote.
Oh, so whether it goes like towards it or away from it.
Yes. So many times in the questions, it will be when x is approaching 90 degrees, which is plus, from the left side. Do you see 90 from the left side? In that case, y is approaching positive infinity. Very important. Behavior
Yeah.
near the asymptote. When x is approaching -90 from the right side, means plus. Do you see that? We are approaching from this side, correct? Then the y value approaches negative infinity.
Negative. Right.
That is the behavior near asymptote, which you could write in the properties of the graph of tangent function. Very
Oh, I
critical
see.
property.
Okay.
Actually, this gives you the 5 points because the 3 points are 0, 0, 45 degrees 1, right? -45, -1. And these 2 points, the behavior near the asymptotes, right? You have already written the asymptotes as odd multiples of 90 degrees, right? So you got
Yeah.
the critical points. You get the idea?
Yeah.
Perfect. And you can see from here that domain does have restriction that odd multiples of pi by 2 are not in the domain of tan theta. However, the range does not have any restriction. It goes from -infinity to +infinity. Clear?
Yeah. So domain has restriction, range doesn't.
Yes. I'd like you to read example 1 now, please.
Oh, okay. So describe the transformation in order in which it should be applied to sketch the transformed graph of the function y equals 3 tan 2x minus 4, and then provide the mapping for the image points.
Correct. How will you do it? Tell me.
Okay. So first thing is to look at the outside. So we can, I'm just describing the transformation and then
Yes,
I'll
yes,
discuss
yes.
the mapping. Okay, so we can see that there is a 3, so that will let us know the like
Vertical stretch.
like the vertical stretch or compression, vertical stretch. And then we've got the -4, so we know the graph would shift down 4 units, vertical translation. You've got the 2x, so the k is 1 over 2. So that's why you would take your image point. So if you want to make your image point as x and y, you would do x over 2, and then it will be 3y minus 4.
Okay, now, whenever you have to
So-
describe the transformation in order, you have to move from left to right. You understand? So
Did I
first
like
thing,
jump around?
yeah.
Oh, sorry.
Yeah. So left to right. First thing you were correct. Vertical stretch by a factor of 3. Now, second will be horizontally compressed by a factor of half. You see that? That too.
Oh.
Horizontally compressed by a factor of half. When you do that compression of factor of half, what happens to the time period? The time period, which was 180 degrees or pi, will now be
Yeah.
90 degrees or pi by 2. It gets shrunk. Do you see that?
Oh, I see.
The whole thing horizontally gets compressed by a factor of half, and then we'll translate the whole unit 4 units down because it is -4. You get the idea.
Oh,
So
okay.
as far as the x and y coordinate points are concerned, you can very clearly see that the x values will now be corresponding to half of the earlier x
Excellent.
values, and the y values will become 3 times
Three.
minus 4. Is that clear to you?
Yeah.
So that becomes the mapping of the image from this transform function,
Yeah.
right? As far as my graph is concerned, I will now make a frame which have a width of not minus 90 to 90, that 40 minus 45 to, so
Four. So minus 45 to 45.
you're getting my point. Yes. So
Yeah.
now I will still draw my lines like this also. Why should I really put them down? But I will write minus 45 here, right? Same graph, right? And now within this graph, this is my original function. I'm not really drawing that. I'm putting these 3 points, 1, 1, and this, right? Of course, when I draw a graph, I will kind of go like this. You see that beautiful curve? I'm
Yeah.
putting it diagonally, very symmetrical, because 1 minus 1, they have to be symmetrical. But the
Right.
graph goes like a sinusoidal saddle point. You see that saddle point, smooth
Yeah.
curve? Make a smooth curve like that, as you get a tan function. But this is not vertically translated. It has only been compressed. Now, with the points of y, which is 3y minus 4, that means you're stretching it and also moving it down, correct? So 1 goes to 3 and then comes back to 4. So when you make your table, you could do it, correct? So if you want to first stretch it, then of course you will stretch this and this will go like kind of like this. Do you see that? And so you have a graph which is kind of like this. And this is a graph which will give you tan of 2x, correct? But we stretch it by a factor of 3. Now
No,
we need
minus
to
4. Yeah.
translate it by minus 4. That really means that we'll pull it down by 4 units. So this every point will come down by 4 units. So you understand?
Yeah.
So
So that's minus 4.
yeah, so I mean, you get the idea, right? So very
Yeah.
easily I've sketched the graph of tan function. It could be like this for you, right? But do you see
That
how
is.
easy it is?
Yeah. Yeah.
Hmm. So, okay. So now we have another equation here, which says transformation included. So I just changed the equation, made it minus 3. So if I make it minus 3, in that case, can you please read what is this?
Uh, yeah. So it reflects it in the x-axis.
Hmm.
Then you have a vertical stretch by a factor of 3, horizontal compression by a factor of a half, and then a vertical translation of 4 units down.
Correct. So basically, when I say reflect on the x-axis, if I'm considering the one of these graphs, let us say, let me just sketch my graph like this, right? Is that okay?
Yeah.
So if I have a sketch of this graph, and let us say, so basically, when I'm reflecting, it will be kind of like, do you see that? This is my vertical
Oh, because
reflection.
reflection in the x-axis. Yeah.
See how
Nice.
easy it is? Just flip it
Yeah.
over. So you got your point, and flip it over, and you get your curve. So simple as that. The idea
Right.
is,
Right.
first make your frame, then you get your 45 degrees points, right? And then you
Yeah.
flip it over. So easy,
I see. Yeah. Yeah.
right? Nothing
Very
can be
clear.
simpler than this. You get the idea, right? Beautiful.
Yeah. Yeah.
So now you have understood all this. Can you please read the notes?
Yeah. So following two orders are also correct as factors relating to multiplication comes before addition. So a vertical stretch by a factor of 3, reflection on x-axis, horizontal compression by a factor of a half, and vertical translation of 4 units down.
Correct.
Or horizontal compression by a factor of a half, vertical stretch by a factor of 3, reflection on the x-axis, and then vertical translation of 4 units down.
Because the first 3 factors are related to multiplication. So you could either say vertical stretch, or you could say horizontal compression first, or you can say reflection first. It doesn't matter. All 3 are multiplication.
Okay.
Correct?
Yeah.
So you could write this order or that order, both are correct. But what I'm trying to say here is, because you know now both are correct. So if I have a general equation, y equals to a tan, and let me write this as k, x
Left from
minus
right.
p plus q, right?
Yeah.
If you go from left to right, you will never mess up. Do you understand?
Yeah. It's better to keep that order. Yeah.
So keep this order, but you could say any of these things first. That is the idea.
I got it. Yeah. Because they're all multiplication. Yeah.
Okay, let's move. So we have a graph which is only vertical. So let's just look into graphs quickly. So if I do 2 tan x, it really means that that point which was at 1, do you see that point which was at 1
Mm-hmm.
has been stretched to 2. Do you see that?
Oh, yeah,
So
yeah,
this point is coming at 2 instead of 1. So I have this 2x. Is that clear to you? The
yeah,
same graph,
yeah.
same 90 degrees. But on the other hand, if I have 3x, I will stretch it by a factor of 3. But if I
3,
have half x inside, then my 90 degrees will become 45 degrees.
45. Yeah.
Again, easy to sketch. Do you see that? So there you can see how I have actually sketched. Oh, sorry, half means double it.
Uh-huh.
Half means
Yeah.
double it. Multiply. I'm so sorry. So it'd be 180 degrees, right? So it'd be 180 here and minus 180 there. Do you see that part?
Mm.
And the point, which is that x equals to 1, now comes at 3. Do you see directly we get the amplitude? I mean, not the
Yeah.
amplitude, the A value.
Yeah. Yeah. I
Nothing
see.
can be simpler than this.
Yeah,
You
it's really
actually draw
clear.
these two lines, and in between, you draw your y value, I mean, x and y coordinate points, correct? Now, you know this point remains here, and at 45 degrees, or midway, I should say, because we are looking into transform functions, correct?
Yeah.
Midway, what am I doing? I'm just plotting the point, which is the value a. You see that a. If I have a tan x,
Mm-hmm.
a tan kx, you see that? So my value here is a. So the point here is the midway between the period. Do you get the idea?
Yeah. Yeah.
So you see, if it is 3, we have 3 here. Do you see that 3 there?
So that's always there. So,
Always.
but it would, but it would
And this
only.
value, yeah, this value is what? This value is 90
Yes.
degrees and divided by k.
And K
And
is a
this
half.
value is 90 degrees minus divided by k. Do you see that?
Mm. So would
Obviously,
that A only be there if it's in that format, A tan KX, or can it just
yeah.
be anything A?
No translation, no translation. This is without
Oh,
translation. So
I
in
see.
tan graph, what I prefer actually is I do both the translations later. In tan graph,
Oh,
I do only stretches and compression first shot, second shot both the translations, because I'm directly getting the value so nicely, right?
oh, okay.
And this value here is 90 degrees divided by twice k, because this is half, right?
Mm. Yeah,
You
I
see how
see.
easy it is. General solution, correct? So that is my first shot at tangent function without translation.
Right, right. That's very
So
clear.
I have actually discussed all graphs which are of this form where only stretches, compressions, and reflections are there. Is that clear to you?
Oh,
Obviously, if I have this as minus, then I will get a value which is minus a, right? Because I'll get a negative value. I don't have to break my head for that,
I see. Yeah, yeah.
right? So it gets
Right.
reflected.
But how do we figure out the X
I
value
mean,
though?
pardon? The
Like,
x
so we
value,
know that the Y value is A.
the x value is 90 degrees by 2k. Okay.
Oh, wait. So wait, with the Y equals 3 tan half X, if I knew that A is 3, then the Y value, I'm going to sub in K as a half into that.
Let me begin again. X and y values for the graph a tan kx, correct? So if my x value is going to be 90 divided by k, then the y value is a vertical asymptote. Do you see that?
Yeah.
Even when I have this as minus 90 by k, I am going to infinitely
Asymptote.
large value. But this is going towards the negative infinity. Does it make sense to you?
Yeah, yeah.
Then I know that if I am at 0, I am at 0. No
Yeah.
problems in this. I got this particular point. And third point is the critical point for you, and which is midway between these two guys, right? 90 by 2k gives me 1, or rather 1a, I should write. Is it okay? Because I multiplied this by a. And
Mm.
minus 90 by 2k gives me minus a.
Minus A. Okay.
So we got the 3 critical points.
Right, right.
For any trigonometric function with tangent, does it make sense to you?
Yeah, very clear. Can I just take a picture of that? Just a
Sure,
quick
sure.
second. Thanks. got it. Thank you.
I'm smiling as if you're taking my picture.
So yeah, definitely. That's why I took it. Yeah.
So now, Amy, this is my graph, that is my equation. This is my graph, that is my equation. How will I write my points? Look here. We are looking into, because I have space here, I can actually give you my points, correct? So let's talk about the vertical asymptotes first, right? We know we have two boundaries. Those are the two vertical asymptotes, correct?
Yeah.
So the value of vertical asymptotes will be x equals 2, and this is my graph, right? So it is 9, I have done it in degrees. So 90 divided by half, right? 90 divided by half. Is that clear?
Yeah.
Which is 180 degrees.
180.
And this value will be minus 180. I don't
Minus.
even have to calculate, they are symmetrical, right?
Yeah.
What am I doing here is I'm giving you points for 3 tan half x, because I don't have to think, right? And then I will do translation. You get the idea?
Yeah, yeah.
Then I will write 0 here and 0 here. I don't have to think, correct?
Yeah.
Half, midway between the x value, which was 180 degrees, right? I got this 180 degrees. I know the x value is half is 90 and minus 90. Is that clear to you?
Yeah.
And the value is a, which is 3 and minus 3. Did I get all the values without calculation?
Yeah. Impressive.
Nailed
That's what
it,
I'm
right?
saying.
It takes a second to make a trigonometric graph, which is like this. And now what we are doing, look here. We'll write down the third value, which is third and final. Let's use some beautiful color here. There's so many. Okay. It's just 3 tan half x, right? Plus 1. Guess what? This vertical asymptote will not change.
Doesn't change. Yeah.
It is same. This is same, right? 0 becomes 1 and 3 becomes 4, right? And this minus 3 becomes minus 2. Did I get my graph?
Yeah.
Check my values. Now check these values. Do you see these values here?
Yeah, so 0, 1.
Do you see these
3,
vertical
4.
asymptotes at minus 180 and 180 degrees, right?
Oh, I see. So always do the horizontal, like just leave the translations, draw that graph first, then do the translation last. Because only from that you can get that point.
If the teacher is not asking for steps, make your table. Do you see how easily I made my table? I got my final points. Plot the points, you are done.
Oh, okay. Now I'm kind of excited to try this. I think I got the knack of that. That's really quick. Are we flying through it then?
That is tangent. Yeah, sounds right.
You've taken my fear away from
no one will ever teach you like I'm telling you. No one has ever seen tangent graphs. They actually go tangent. Last time also too, right? But they're so simple. You just grasp them like this. How can they go like that? Come on, man. Just grab them. Okay, good.
It's really clear. Yeah.
If I write minus here, look here. I'm just making another example out of the same.
Flip it.
Just flip it, man. This is minus. See, this is an invariant point. At 0, it will remain. Do you see that? Keep this point same and just flip
that doesn't change.
Done. Just flip it. You get the
idea. Do that to every part of that. Yeah, got it.
Good.
Yeah.
We'll see soon. Cotangent is kind of flipping the tangent, right? So we'll see that.
Okay. Do I learn that? Cotangent.
Yeah. Reciprocal of that. It's so simple. See, 1 over square root 3, reciprocal is square root 3.
Yeah.
What is the reciprocal of square root 3? 1 over square root 3, done, right?
Oh, okay. So that relation between them, it's easy.
Very simple. So that is what I was saying. There's nothing simpler than the tangent graph, right? So there's more to it. So basically for tangent, when actually we are soon coming to it. So cot is 1 over cot theta is 1 over tan theta, correct?
Yeah.
We'll understand reciprocal function. That becomes now the asymptote. Do you understand? The frame also changes by 90 degrees.
Okay. Yeah. So that we just have to be along.
The first thing is the frame change. You get the idea? And then we'll draw the graph. So we'll just look into this, right?
Okay.
So I showed you the result, but it will come to the similar result.
Yeah. Just the frame changes.
Frame is going to change. Okay, is that
I see. Yeah.
We'll look into this. So we work with two things, and that is we work with the frame, right? So everything is context to what tan is this frame, And within this frame, tan function, what I'm trying to say here is something like this. Coming back to this, let me make it clear. So tan function is this within the frame. Is it clear?
Yep.
So this is tan. And for the cotangent, it is always decreasing. So it is kind of thing. It is decreasing, right? How?
Yeah.
The points here are different, right? For tan, this is like 90 degrees plus and minus. Is that okay?
Yeah.
But this cotangent shifts, right? So it is from 0 to 90 degrees.
Oh.
So
Okay.
it shifts by 90 degrees to the right because it's a co-function, right?
Only one side shifts though.
Both.
The minus 90 moves.
Oh, sorry. 180.
Oh.
So it shifts by, it's a
By
co-function,
90.
right?
Yeah.
You understand? It's a co-function, right? Because we know that tan of, because in a right triangle, we know 90 minus theta is basically cot theta.
Okay.
So it's
I don't think, yeah, that's just
co-function.
something you need to know.
But the shape is kind of reversed. You get the idea, right?
Yeah,
so
yeah.
the shape is kind of what you see with
x-axis.
minus here, but it shifts, right? Is that clear?
Yeah, yeah.
Okay. Now we'll get to cotangent soon, but let's look into tan. In tan, what now we have done is taken up minus, right? So when I do minus, then my graph is always decreasing. Do you see that?
Yeah. So it's just all the same points, but reflected in the x.
Opposite, yeah, the flip, right? So this point, which was here at 3, the point came down, and the point which was here, it went up. Do you see that reflection? Yeah. Because of this minus. Is that clear to you?
Yeah.
And so obviously the graph gets decreased, and therefore we can now look into the graph in so many different ways. Now here we have example 5, which is write tan function from the graph, correct? This is the reverse question, correct?
Oh no. Yeah.
So can you please read the right? So let me just erase this part. All right, decrease. Can you please read this question?
Yeah. So example 5, write the tangent function of the form y equals a tan kx plus q for the following graph.
Correct. How will you do it?
So first, I look at the asymptotes.
Yeah. So it is the reverse thing which we are doing, right?
Yeah.
So earlier, we were trying to get the graph from the equation. Now from the graph, we will get the equation, correct?
Yeah.
So what we are important thing, frame, right? So first thing is frame, right? Vertical asymptotes. Where are the vertical asymptotes?
There's
you
one
read
at.
So go to 0, initial value, right? So these are the two vertical asymptotes, correct?
So 90 and minus 90.
90 and minus 90, have they shifted?
But pi is
no.
180. Yeah, so no.
No, right? So minus pi by 2, I think the scale is in this, right? Radians, correct? Is that clear to you? So there is no horizontal shift. It is clear because from the equation also it is clear there is no horizontal shift. Is that clear to you?
Yeah.
So from the k value, if it is the same value, so between these two, what you can say is between these two, between these two, we have the value which is actually pi by 2, not pi. So pi by 4 it is. You can't read this. That is why you are having a difficulty. Wait.
Is it 45?
45. Because pi is there. Do you see this pi
here? Sorry, it was really small. Yeah.
It's small, right? So
okay,
it is
so
from
45.
minus. It is minus pi by 4 to pi by 4. Is it okay?
Yeah.
Because this is pi by 2. Is that clear to you? This is pi by 2, right?
I think that's pi by 4. Oh.
So 0 to pi, this is pi, correct? And then this is pi by 2. And this is half. This is pi by 4. Is that clear to you now?
Mm-hmm.
So instead of 90 or pi by 2, it is pi by 4. That means the k value shrunk, correct? So that means the value of k is basically 2, right?
2. Oh, okay.
You get the idea, right?
Yeah.
Now, the value, because you have to read the graph accurately. Now, Q is very easy to find. You have to only see the center point. How much down did we go? Do you see that on y-intercept, we went down by -1.
Minus
Right?
1.
So
So
Q is
Q is
equals to
-1.
-1. Is that clear to you?
Yeah.
Now, uh, this value A has actually come down to 2. So originally it should have been at 3, right?
Yeah. So A is 3.
So A equals. Or the value of A you can find by checking the two values and dividing by half. So 2 plus 2 plus -4 divided by 2 is what?
-1.
And that is Q.
Oh.
Correct?
Yeah.
And now from the value of Q, you can take the maximum value, which is maximum. Let me write down here, big and bold. Maximum is what? 2, right?
Yeah.
Minus of -1 is what?
2. 3. Sorry.
So you get the
Yeah.
value of A. You get the idea.
Yeah.
So what I'm trying to say here is that the value of Q is equal to max plus minimum divided by 2. What I'm saying, I should not say max and minimum. The key points. I mean, you understand these points?
The maximum key point and the minimum key point.
We want to do that. We are working with 3 key points. You get the
Yeah.
idea?
Yeah.
Max means the value which was at pi by 4, kind of, in the original
Yeah.
function.
Right.
Yeah, we're only
Yeah,
working with 3 points, right? Our 3 points are 0, pi by 4, and minus
4
pi
to
by
5,
4
minus
in
45.
the
Yeah.
original function, right? So we are looking into these 3 points. Is that clear to you?
Yeah.
Those
That's really
3 points are shown on the graph always.
Oh,
That's
right.
standard.
Because they're easy to plot because they're all
Accurate.
one.
They're
Yeah.
accurate to calculate. Nobody is going to calculate with square root 3, right? So
No.
Q values, add them, divide by 2, just as you do, with the sinusoidal function. Same formula, right?
Right.
So what is
Yes.
the amplitude A equals to? A is the maximum, right? Plus Q, right? You go that much above it, right?
Yeah. But
Yeah.
because it's infinity, does that amplitude make a difference?
No, not that amplitude. The A
Oh.
value in the example, this.
Oh, sorry.
We do not
Yeah.
call it amplitude. The A factor, vertical stretch factor.
Oh, okay. Yeah.
Got it?
Yeah.
So straight away from the graph, we got the value of A, and from the period, we got the value of K. Got it? Because the period is reduced to half, we got K. Doesn't make
Yeah.
sense to you?
Very clear.
Yeah, we went hurriedly over it, but I think you got a
Did we?
bigger idea.
It didn't feel
Anyway,
like we were rushing.
Can you please read this?
Okay, so transformation of trigonometric functions. So the vertical asymptotes are pi by 2 apart. The period is p equals pi
by
over 2, and k is pi over p, and that equals pi over 2, which is 2. The position of center point B, which is 0, -1, and then there's a vertical translation of 1 unit down, so Q equals -1. And then you've got position of the A, which is pi over 8, 2, and it's 3 units higher than B. So that implies that the vertical stretch by a factor of 3. So A is 3.
Correct?
Yeah.
So I'm talking about this graph. Do you understand?
Yeah.
So we're talking about these 3 points. And from these 3 points, we actually made a table. So originally, on the tan function, we know these points should have been at this place, correct?
Right. So we transformed it.
But after the transformation, we got these points, and clearly we can read the values of A, K, and Q directly. You get the idea?
Yeah.
So that note will explain you.
So the observation for deriving the equation y equals a tan kx plus q can be summarized as follow. A is a vertical distance between point A and B. K is pi over p, where p is the difference in x values of the vertical asymptotes. Q is the vertical translation of center point B from the x-axis. And then decreasing tangent curve indicates the reflection, where A is less than 0.
Correct. Now, in this case, you should also see there's no horizontal translation, so I could say this is y-intercept.
Oh, right.
You see how easy it becomes now?
Yeah, yeah.
Very easily from the graph, which is tangent graph, we can actually get directly the equation within seconds.
Mm. So did we know there was no horizontal translation because the asymptotes were in the places they should be?
Yes, and second, we are given the equation which says A tan kx plus q. Kx means no horizontal translation.
Right, right.
Correct?
Yeah,
Also, you can observe from the symmetry, correct? If both the vertical asymptotes are symmetric about the vertical axis, that means no horizontal translation.
right,
There's
right.
only stretch and compression. You get the idea?
Yeah, yeah.
So that clearly indicates, right? Now, sometimes we are not really showing you the other half. For example, in this case, we are only showing you the tangent graph on the right side of the axis, right? Y-axis, right? So majority, you cannot see the left side. So now what you have to do is you have to see what is this time period. Correct?
Always look for at least 2 asymptotes for the time period.
So this is your time period for, actually that gives you time period t, or I am saying period in this case. It is from 2 to 6. 2 to 6 means what? 6 minus 2 is 4, correct?
Yeah.
But we know that time period should have been 180 degrees or 2 pi or pi, correct?
Yeah.
So the value of k will be equals to pi divided by 4. Do you see that? So we got the value of k directly from this time period, which is the vertical asymptotes.
Yeah, yeah.
Now, this point, which is the vertical asymptote, vertical 1, means that the translation up and down q is only by 1 unit. So we get the value of q, correct? Now we see from this value to this value, what is the difference? So it is from 3 to 1, difference is 2, so we get a equals to 2. Do you see a? How easily we got the whole equation? A, K, Q, D. Done.
So to find a, is it just any 2 points?
No, we have to find this vertical, the center point and the next at 45 degrees. I mean, relevant. Do you understand?
So can it be center and the minimum key point?
Yeah. Same thing.
Okay.
Same thing.
Just checking.
See how easy it is?
Yeah. So a.
So here we go, right?
Yeah. Very clear.
And now, okay, one more thing which you have to see. This graph is decreasing, correct?
Yeah. So you have to have a minus.
A is minus.
Correct? Minus 2.
You get the idea?
Oh, that was a key point. Yeah.
So the vertical asymptotes are 4 units apart. So the k value is pi by 4, correct? The position, I should say the y-intercept is at 1 and therefore q is 1, correct? The curve is decreasing, not increasing. Therefore, a is less than 0, right?
Yeah.
And we found that the difference is 2. And since a is less than 0, it has to be minus 2.
Right.
Can you please understand? Read this and understand. Do you have any doubts?
I don't have any doubts. Should I read it again?
No, don't.
Oh, okay. No, it's actually really clear in my head.
Yeah, because now we'll actually quickly go through the cotangent, but I'll teach you cotangent next time. Here's the cotangent graph, which is 1 over tangent, correct? So whenever the tangent graph is 0, cotangent will be undefined, correct? So cot is reciprocal of tangent, right? So we are talking about the reciprocal now, right? Is that clear to you?
Yeah.
You cannot divide by 0. That means wherever in the center it was 0, right? Tan function. Now we are going to have a vertical asymptote. So that means for cot at n pi will have vertical asymptotes, right?
Yeah.
And wherever the vertical asymptotes were there, we'll have zeros. So at 2n plus 1 pi will have zeros, right?
Yeah.
This is for cot. Do you see how we have changed all of a sudden? So these
only because of
move.
Yeah, only because tan x can't equal 0.
And the graph will be always decreasing because tan was increasing.
Right.
With that, you can actually sketch cotangent graphs. Do you understand? You know, 1 over square root 3 will become 3, and 3 square root 3, and square root 3 will become 1 over square root 3. And therefore, the key values will be as shown in this particular graph, correct? We just switched it, correct? I'm quickly going through it. We'll go through it. It is and the graph will look like this. Instead of increasing, it will be decreasing. And as you can see, now we are working in the domain which is pi,
Hmm.
0 to pi. Do you see that?
Yeah.
And the graph is decreasing as shown.
Right.
That is cotangent function. Perfect. We'll end
Very
here our
clear.
class today. How?
Okay.
I'd like you to explore cotangent function also and look into the transformation of tangent function. Correct?
I will do. Yeah. It kind of looks a bit straightforward now because I know tan quite well.
Yes.
Cotangent is just the same principle, just the frame shift. Frame has moved. Yeah.
Perfect. So can
From
you
0 to
summarize
pi.
today's class? And how
Yeah.
comfortable do you feel with sketching tangent functions?
Yeah, so I started off with tan graphs being like my major fear because I just didn't know my way around it, especially in year 12. So yeah, this is like a major breakthrough for me, I feel, because I didn't realize I could do it. Just knowing those three key points is really important for me because like I explained in the beginning, root 3 and stuff are really hard to deal with. Even if you had your scale in in radians and you could just use the pi over 4 and stuff, it's still not like a comfortable thing for me. So just knowing I have 0, 0, minus 45, minus 1, and 45, 1 are just three good points to work with.
Yes.
And then because I guess the asymptotes give you that frame, you can't really go wrong because you know all the other features of tan graphs, meaning always increasing, the behavior around the asymptotes. You're going to know how to draw it. And then once you plot those 3 points, it already comes, so you just draw it. And then we learn how to, if you get a graph, find the equation from that. Again, using the same principles from what we use with sine and cos, but it was slightly different in that when we put aside the translations, without any like sort of calculations using the calculator or anything, you can just like find all the points by looking at, so leaving the shifts, just finding those a values from the graph, knowing your asymptotes, finding the time period by doing pi over k. So yeah, it all makes sense, and just following the same steps, I think it can do some questions. So
Correct.
yeah, thank you so much, sir, for
That's my
taking that off my
pleasure.
head. It was quite hard just having that
Yeah.
over me. Yeah.
And the key thing which you have to remember is that the sinusoidal functions have a period of 2 pi or 360 degrees, and the
Right.
tangent functions and the cotangent functions will have a period of
180.
pi or 180 degrees. These are odd functions repeated after every 180 degrees of pi, correct?
Right.
And so that makes it much simpler. We have to now only work from 0 to 90 degrees to get the whole picture of
Right.
tangent graphs, correct? So that's
Yes.
very, very good. And I'm happy that you've understood most of the concepts.
Me
Practice
too.
is perfect, right?
Yes. Thank you so much.
Yeah,
So
my
that was
pleasure.
so helpful. I really appreciate it. And yeah, and have a good rest of your day.
You too. Thank you. Bye.
Bye, sir.
Bye.